Welcome to the Algebra 1 review video for Unit 3, which is all about exponent rules. So for this test, you are going to have a non-calculator section and a calculator section. So just keep in mind as you're doing this review which section you're in so that you are prepared for what is coming up. So starting with the non-calculator section, number 1, we have 3 cubed times 9 to the 0 power. 9 to the 0 power is 1, and remember, anything to the 0 power is 1. So this is really like 3 cubed times 1. 3 cubed, though, is 3 times 3 times 3. So 3 times 3 is 9, and 9 times 3 is 27. So our answer is 27. For number 2, we have 8 cubed times 8 to the negative 5. Since these bases are both 8, that means that we can just add. And so we are going to add 3 plus negative 5, which is negative 2. So this is 8 to the negative 2 power. So then, since this is a negative exponent, we have to put it downstairs, and so it's going to be 1 over 8 squared like that. And then we have to simplify that because we can do 8 squared, which is 64, so it is 1 over 64. Okay. For number 3, we don't have anything that can simplify, but we do have negative exponents. And so with these negative exponents, we just need to change where they are. So the 4 gets to stay because its exponent is not negative, but the x to the negative 2 does need to move because it's negative, so we're going to move it down to the bottom. And then y to the negative 7th on the bottom, since it's a negative 7, we're going to move it up, so it is y to the positive 7 instead. And you do not have to do anything past that. So then for number 4, we are going to add because we are multiplying. So we have p to the 1/3 and p to the 1/6. So if you want, you can write it so that they're next to each other. Some people might find that helpful. Some people might find it obnoxious. But since these are getting multiplied, we have to add our exponents. So 1/3 plus 1/6 in the case of p. And so if you look at this, 1/3 and 1/6 do not have a common denominator, but 6 would be a common denominator. So 3 times 2 gives me 6. So 1 times 2 gives me 2. So it'd be 2/6 instead of 1/3. And then 2/6 plus 1/6 is 3/6, which can be simplified to 1/2. So you can just have p to the 1/2. And then with your q, we have 1 and negative 6. So when we add 1 plus negative 6, which is like 1 minus 6, that would end up giving us q to the negative 5 power. But remember, your exponents always have to be positive. So we're going to have p to the 1/2 on the top. And then on the bottom, we're going to have q to the 5th because you have to change its position if you want to get rid of that negative exponent. So then for number 5, we're still multiplying. When we have numbers like this negative 6 and 4, we're going to multiply them together. So negative 6 times 4 is negative 24. Then we have our c's and the d's. So if we look at the c's, we have 3/5 and 2/5. 3/5 plus 2/5 would be 5/5, which is also 1, so you can just write it as 24c. And then d has d squared and d to the 1st power. Remember that it has a little 1, so this would actually become d cubed. Oops. And things do not combine, so we just leave it like that. Okay. For number 6, we have this r to the 9th power to the 1/3 power. When you have a power to a power, you multiply. So we're going to do 9 times 1/3, remember, which is like 9 over 1. And so you can cross simplify because 9 and 3 share a 3. And so 3 divided by 3 is 1, and 9 divided by 3 is 3. So that gives me just 3. So then that would leave me with r to the negative 8 times r cubed. And now since we're just multiplying these r's, we can just add. So negative 8 plus 3 would give me negative 5. So this would be r to the negative 5th power. And then because it's a negative 5, I have to put it in the denominator to make it positive. So it's 1 over r to the 5th power like that. Okay. For number 7, we have this 4th power out here. And so we're going to have to distribute that to everything. So it goes to the 3. So I will just write it as negative 3 to the 4th. Then we have 7 and 4, so we are multiplying. So 7 times 4 is 28. And then v is to the first power, and 1 times 4 is 4. So then we have to simplify this negative 3 to the fourth power. Negative 3 times negative 3 times negative 3 times negative 3 would make 9 times 9, and 9 times 9 is 81. So then this would become 81 u to the 28th, v to the fourth. Keep in mind, if multiplication is hard for you, you might want to brush up on some of those before the test rolls around for this non-calculator section. All right, so then for number 8, we are still going to be multiplying this 6th power to the others. So if you need to, off to the side, you can do 2/3 times 6 over 1. The 6 will simplify with that 3, so it's 6 divided by 3 is 2, and 3 divided by 3 is 1. So then 2 times 2 is 4 over 1. So that means I would have a to the fourth power. And then for b, that's 5 over 12 times 6 over 1. And so cross simplifying again, we can divide 12 and 6 by 6. So that would give me 1 and 2. So then 5 times 1 is 5, and 2 times 1 is 2. So b is still going to have that fraction where it's 5 over 2 like that. Okay, so then for number 9, notice we have numbers to multiply, but we still have to follow order of operations. We still have to take care of those extra exponents before we can do all of the other stuff. So we're going to distribute this cubed to everything. So we'd have negative 2 cubed. M cubed cubed would be 3 times 3, which is 9. And then we'd have n to the fifth cubed. And so 5 times 3 is 15. And I'm going to keep the parentheses just so I can keep them separate. But I'm going to do the same thing to this one over here. So I'm going to distribute that squared. So we'd have 3 squared. M, we're going to multiply the exponents. Negative 7 times 2 is negative 14. And n also gets the 2, and it's just going to be n squared. So then, once you do that, then you can kind of start simplifying. First, we want to get rid of these numbers to simplify them a little bit. So negative 2 cubed would be negative 2 times negative 2 times negative 2, which would be negative 8. So we can keep everything else the same over here. And then we are multiplying by 3 squared, which is 9. And if you want, you could move that m to the negative 14th. It just kind of depends on your preference. I'm just going to keep it for now because I'll take care of it in the next step. So negative 8 times 9 gives me negative 72. And then with the exponents, we're going to add them. So 9 plus negative 14, or 9 minus 14, would give me m to the negative 5, because 9 plus 5 is 14. And then with n, we would have 15 plus 2, which is 17. So then, even though all of this is pretty well simplified, we do have to take care of this negative 5. So in order to write that in an equivalent form, we would have negative 72 n to the 17th over m to the 5th. And again, that negative 5 becomes positive when you move it to the denominator. So then for number 10, we are going to simplify again. We have f and g in the top and the bottom, so we can combine them. When we are dividing, we want to subtract our exponents. So if I have f to the fourth and f to the negative 6th, 4 minus negative 6 would be like 4 plus 6, which is 10, which means it's going to be f to the 10th power. And then for g, we have negative 2 minus 1, which is negative 3. So that would be g to the negative 3. Or, to write it in its simplest form, we keep the f to the 10th on the top, and g cubed is going to be on the bottom like that. Okay? Another way you could also think of it too is that this f to the 6th would have to move up if you were to change with those negative exponents. So then that would become a positive 6, and then 6 plus 4 is 10. And then this negative 2 with the g would have to move down, so then you'd have 2 plus 1, which is 3. So if you'd rather move the negative exponents beforehand, that's totally fine as well. So then for number 5, since it is to the negative 5th power, we are going to flip what is inside of the fraction. So this is going to be e to the 4th over 2c cubed to the positive 5 power now. And then with that positive 5, we're going to distribute it to everything. So we're going to have 5 times 4, which is 20, so e to the 20th, over 2 to the 5th power. And some of you make sure you are writing your exponents as exponents, not just the number next to it. But then 5 times 3 would give us c to the 15th. So then you just have to figure out what's 2 to the 5th power. Well, if you don't know, write it out and do it the long way. 2 times 2 is 4. This 2 times 2 is 4. So I have 4 times 4 times 2. If I do 4 times 2, that's 8, and 4 times 8 is 32. So e to the 20th over 32c to the 15th. And again, if your multiplication rules are what you think is going to trip you up, make sure you review them because it will make your life much easier if you know them. So then last but not least, with this section at least, we have division again. Since it's division, we're going to subtract. So we have 5/3 minus 1/3, which is 4/3. And so you would just write 8 to the 4/3 power. Right, boop, 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 just like that. Okay. So for number 13, we want to evaluate, and we're going to do the same thing for 14 and 15 as well. But if we start with 13, personally, I like to simplify these before I plug in. So since I see this x to the negative 4th, I know that needs to move down to the bottom. So I'm going to have x to the positive 4th. And then I'll plug in the actual values. So y squared, y is negative 3. So negative 3 squared over 2 to the 4th. Negative 3 times negative 3 is positive 9. And 2 to the 4th, well, if you look up where I had it before, this would be this part, so then it'd be 4 times 4, and 4 times 4 is 16. Okay? For 14, we can simplify a little bit because z to the 0 power is just going to be 1. It doesn't matter what z is worth. So that is just going to leave me with 7 on the top. But this x to the negative 2 also needs to move up. And so because of that, I'm actually going to have 7x squared. So then when I plug in my x of 2, I can only square the 2 because that's what's next to the squared. So this would become 7 times 4, and 7 times 4 is 28. Okay. So then with 15, we are going to rearrange a little bit because this x to the negative 1 is negative, and I don't like that. So this would on the top become 4xy over z squared. So then you plug in what you know. We would have 4 times x, which is 2, times y, which is negative 3, all over 5 squared. And so 4 times 2 is 8. 8 times negative 3 is negative 24. And 5 squared is 25. So that would give us negative 24 over 25. Okay. So for numbers 16 through 18, we want to write the expression in radical form and then simplify if possible. So remember when we're doing this, you write your base, you draw your radical, the number on the top is inside, and the number on the bottom is your index or your number on the outside. So this would be the 8th root of p cubed, and we cannot simplify that. So then we have 32c to the 1/5, and so we would have 32c, and I'm going to put this in parentheses because this is to the first power on the inside, but we're taking the 5th root. And the reason why this is important is because 32 is also getting the 5th root taken. So the reason why that's important is if you break down 32, it is actually 2 times 2 times 2 times 2 times 2. So that means that 32 is actually like 2 to the 5th. And if I'm taking the 5th root, 2 to the 5th would just move out and become 2 5th root of c, like so. So we have to simplify. If you didn't put it in the simplest form, then you would just lose some points because of that. But again, you just want to simplify as much as possible. So then for 18, we have 125. Gee, it'd probably help if I wrote the 5. And I'm going to put this in parentheses again because this is squared on the inside, but we're taking the cubed root. And so this one you have to be careful because we can't do anything with the g squared, but the 125 we can do something with because 125, and actually I'm going to expand this a little bit. This would be like 125g times 125g. But here's the thing. 125 is 5 times 5 times 5, which means I have two groups of 3, which means both of those get to move out. So then I have 5 times 5 on the outside, which gives me 25. And then we still have the two g's on the inside. So that would be cubed root of g squared, like that. Okay, now if that one's the one that gives you issues, I would not worry as much. But again, try and break it down if you can, because when it's a cubed root, you're looking for groups of 3. If it's a square root, you're looking for groups of 2, and so on and so forth. Okay, so for number 19, we want to write this in exponential form and simplify if possible. So in 19, a is to the first power, and so this would be a to the 1/7. Just like that, nothing fancy like that. So then for 20, we are going to remember that this is the denominator all the time. So I'm just going to write it with a denominator, 20 over 10 and to the 6 over 10. And then we can simplify. 20 over 10 is just going to be m squared, and 6 over 10 would simplify to 3/5 because you can divide both the top and the bottom by 2. So then last but not least, 81d squared, and it's the fourth root. So this is where you need to be careful because that 81 is to the first power. So this is 81 to the 1/4, and then d squared divided by 4. So 81 to the 1/4, you have to break this down and see if you can make a group of 4. So if we break down 81, that's 9 times 9. And 9 breaks into 3 times 3 for both. So if you notice, I have a group of 4, which tells me that 3 is the fourth root of 81. So instead of having 81 to the 1/4, we're just going to write 3. And then d, instead of 2 over 4, we're going to write as 1/2. Just like that. Okay? So now we are to our calculator section. Woo woo! If you've been on the struggle bus, again, just try and practice without a calculator. Make sure you can do this stuff without it. So with simplifying radicals, we are going to start by trying to find a perfect square. 72 is made up of 9 times 8. And so 9 times 8 is 72. 9 is a perfect square, so that gets to move out. And when it moves out, that gives you a 3 because the square root of 9 is 3. So then that gives me 3 root 8. Ooh, actually, just realized it does give me 3 root 8. But what you'll notice is that 8 also breaks into 4 times 2. And if 4 is a perfect square as well, that gets to move out, which brings out a 2. And so 3 times 2 gives me 6 square root of 2. So if you ever are doing this and you realize you don't take out the biggest perfect square, it's not the end of the world. You just need to break it down a little bit farther, bring out the rest of the perfect squares, and get your final answer. Because ultimately, if the number inside the radical is as simple as you can get it, it's fine. If it's not, just take the extra step and do it real quick. So for number 23, we need to break down this 45 and a and t and u to the 5th. So I'm going to do it this way. So we're going to have one radical where I know I have to simplify stuff and one where I know I don't. So with 45, that would break into 9 times 5. And 5 I can't do anything with, but 9's a perfect square. But then t to the 8th, that's an even number, and I have an even index, so I can leave all of those in there. But then u to the 5th, if I put u to the 5th, I'm going to have some stuff left over. So I'm going to take the closest even number I have, which is 4, and I'm going to say u to the 4th. And since I have 4 u's in this set, I just need to put 1 u over here. Now, the benefit to doing this way is that it's already pretty well organized for you, and the worst case is if you make a mistake, you can find it later. But we simplify what we have. Square root of 9 gets to move out. It brings out a 3. T to the 8th. When it moves out, you're really doing like 8 divided by 2 because this is a radical. So this would be like t to the 4th. And then u to the 4th, when it comes out, it would be u squared because, again, you're cutting that exponent in half. So then I would be left with 3t to the 4th u squared, and then the square root, and I just realized I messed up because I forgot about the 8. Don't forget about the 8. These are all outside. So 3 times 8 gives you 24. And then 24, t to the 4th, u squared. Then you keep your square root of 5u. And notice, it's really easy to make a mistake and miss something and accidentally leave something out. So make sure you check your answer. I can't stress it enough. So for 24, we are multiplying. So we're going to have negative 9. And then we can just multiply the radicals together. So that would be square root of 48. 48 breaks into highest perfect square. I want to say is 16, but I'll double check. 48 divided by 16 is 3. So you'd have 16 and 3. So square root of 16 is 4. So we would have 4 times negative 9, which is negative 36. And then we'd still have the 3 on the inside, so it's negative 36 square root of 3. So then for number 25, we are going to be multiplying these again. For me, it's easier just to multiply them and then simplify them. I don't know why. I think it's partially just personal preference. But 3 times 21 gives us 63. And again, these are in the radical. And then e to the 4th times e to the 7th, we are just adding. So 4 plus 7 is 11. So then we need to break it down. 63 breaks into 9 and 6. E to the 11th would break into e to the 10th because, again, I want an even number because I have a 2 over here even though it's not written in. Didn't mean to do that. But then we would have a single e in the other one. So then square root of 9 is 3. Square root of e to the 10th is e to the 5th because you divide it by 2. And then you keep the square root of 6e there. And voila. So then for number 26, even though it looks kind of ugly, all you're really doing is taking the square root of the top and then the square root of the bottom. So with 24, if you just come off to the side, 24 breaks into 4 times 6. And 4 is the only perfect square in that, which would give us 2. So instead of having this as 24a to the 6th, this is like 4 times 6, and we can keep that a to the 6th with the 4 all over. Square root of 9 is 3. So then the square root of 4 is 2. Square root of a to the 6 is a cubed. Square root of 6 just gets to stay there, and it's all over 3. And we cannot simplify because the 6 is in the radical, so we can't divide it by 3 all willy-nilly like. So for number 27, we are just subtracting. And since what is inside of the radicals is the same, you know you just have to add or subtract the numbers in the front. So in this case, we would have 1 minus 5. 1 minus 5 is negative 4. So this would be negative 4 square root of 7. The end. Now, a little bit more complicated with number 28 because if you notice, they are not the same quite yet, but we can make them the same. So, possibly at least. Square root of 27, we can break that into 9 and 3. Square root of 9 is 3. So 3 times the 4 that was already there would give us 12 square root of 3. And I'm going to rewrite the other one, so 5 root 3. Now, since they both have the square root of 3, it becomes 5 plus 12, which is 17. And it is 17 square root of 3. For number 29, we have to distribute. And remember, you are multiplying whatever is outside with anything that's outside, anything inside the radical with whatever's inside. So when we do 3 root 10 times root 5, 3 is getting multiplied by 1, so that gives us 3, and root 10 times root 5 is root 50. And then when we multiply 3 root 10 times negative 7, we have 3 times negative 7, which is negative 21. And then root 10 has nothing to multiply with, so it just stays there. Now, although it's tempting to leave the answer like this, you do have to simplify it to make sure they can't combine. And so 50 breaks into 25 times 2. Square root of 25 is 5, so 5 times 3 gives me 15 root 2, because that's all that's left, minus 21 root 10. And there's nothing I can do with 10 because it is made up of 2 times 5, and both of those are prime numbers. And so my final answer, even though it's not that pretty, that is my final answer. So then for number 30, we are again multiplying. So we distribute this square root of 2 to everything. 9 root 8 times root 2 would give us 9 root 16 because you're just multiplying the 2 and the 8. And then you're going to multiply the root 2 times the root 6. And so root 6 times root 2 is root 12. Square root of 16 is 4, so this becomes 9 times 4, which is 36. And then 4 root 12, 12 breaks into 4 times 3. Square root of 4 is 2. And so 2 times 4 gives me 8 root 3. And again, you have to give it to me in simplest form, so don't think you can just leave it like the top line. You do have to actually break it down and simplify it all of the way. So for 31 through 33, make sure you can do these, because if you can't do these, it will totally botch your test. But, I'm telling you now. But when you have to solve equations like this, you want to get the radical by itself. So I'm going to start by subtracting 5. That would give me the square root of 2x equals 4. Now, because that is by itself, I'm going to square both sides, because when I square both sides, that gives me 2x equals 16. And then, if 2x equals 16, I can divide by 2, and x equals 8. Voila. Now, quick check, because it is very strongly recommended. Square root of 2 times 8 plus 5 equals 9. 2 times 8 is 16. Square root of 16 is 4, and 4 plus 5 is 9. So we are good. All right, so then with 32, we look. This radical is already by itself on one side, so we are going to just square both sides as our first step. And when we do that, that gives us 5w minus 6 equals 64. So then we are going to add the 6, because now it's just like solving a regular equation, which gives us 5w equals 70. And then we would divide by 5, which gives us that w equals 14. And again, check yourself. It doesn't take very long. Square root of 5 times 14 minus 6 equals 8. Well, 14 times 5 is 70, minus 6 is 64, and the square root of 64 is 8, so we are good. So then with this last one, again, both of these radicals are already by themselves, so don't overthink it. You're just squaring. When you square it, you get 3r plus 1 equals 7r minus 11. And so then you're going to just solve the equation. Personally, I would subtract the 3r first so that I can have positive r's on one side by themselves already. Then I would add the 11. So I have 12 equals 4r. And then last but not least, I would divide by 4 so that r equals 3. And then again, your quick check, you would have square root of 3 times 3 plus 1 equals the square root of 7 times 3 minus 11. 3 times 3 is 9 plus 1 is 10. And 7 times 3 is 21 minus 11 is also 10. So we are good again. So then 34, we have the radius of a cylinder is given by the equation r equals square root of v pi over pi h, where v is the volume and h is the height. If the radius of the cylinder is 3 centimeters and the height is 2 centimeters, what is the volume of the cylinder? So since I want the volume, I know I need to plug in r and h. We know we're plugging in 3 for r and 2 for h. So instead of having r equals the square root of v over pi h, I'm going to plug in 3 for r and 2 for h. Now, if you notice, this is a radical equation. And so to solve this, we are going to start by squaring both sides because that radical is already by itself. So that would give me 9 equals v over 2 pi. And so if I'm trying to solve for the volume, that would be v. So I'm going to multiply by 2 pi to cancel out the divided by 2 pi. And if you notice, we said round to the nearest tenth of a centimeter. And so you pull out the handy dandy calculator and make sure you use your pi button, which mine, boop, 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 there it goes. Come on. So we're going to do 2 times 9 times pi, which gives us 56.548 for volume. And so just a quick rounding review. If I am rounding to the nearest tenth, that's this 5. And so I look to the number next to it. 4 tells me to keep it, so I'm going to say 56.5. And I want to say this is going to be centimeters. Yep, centimeters cubed equals volume. Now, if you're wondering, but hey, Miss Hall, there's an 8 there, which would round the 4 to a 5 and then make the 5 a 6. Not how it works. If I was rounding to the nearest hundredth, I would care about the 8. But since I'm rounding to the nearest tenth, I am not caring about the 8. So that is the end of your review for the final for Unit 3 test. If you have any questions, please comment below. Make sure if the video is helpful that you like and subscribe so that you get notifications of new videos every time they're made. And again, let me know if you have any questions or anything.